We will see a few more examples for the for loop. So I have an example here. Currently we will not use n, we will use it later. So this program calculates the sum of numbers till 5. You can see we have 5. It adds all the number from 0 to 5. So we have declared one variable sum and one variable I. Sum is initialized to 0. So in the first iteration, I is equal to 0 is the first step. 0 less than 5 is less than or equal to 5 is true. So sum is equal to, sum is 0 plus 0. Sum becomes 0 again. Next, step 4. This is the step 3. Execution of this statement is the step 3. Now step 4 is increment. I becomes 1. So 1 less than or equal to 5 is true. So now sum is 0 plus I is equal to 1. 0 plus 1, sum becomes 1. So next, after this execution, I increments to 2. 2 less than or equal to 5 is true. So now sum is equal to 1, I is equal to 2, 1 plus 2, sum becomes 3. So next I becomes 3, 3 less than or equal to 5 is true. So 3 plus 3, sum becomes 6. Next I becomes 4, 4 less than or equal to 5 is true. 4 plus 6 is 10, sum becomes 10. Then I becomes 5, here I increments to 5, 5 less than or equal to 5 is true. 5 plus 10 is 15, sum we get 15. Next I increments to 6, 6 less than or equal to 5 is false, so this exits the loop and the loop statements are not executed. And now the sum is 15, so sum of the number is 15, so it prints 15 in the place of percentage %d. The sum is 15. So we'll see this. We'll save and we'll do Alt F9 to compile the program. We'll do Control F9. Okay, so now it says sum is equal to, sum is 15. So this way we can execute. If we want to debug this program, so we will use, there's no bugs right now, but still if we want to see what exactly happening in the for loop, we can do this. We'll print the I value. I is equal to percentage %d. Sum is equal to percentage %d. We'll print both sum and I. So we'll save the program. I'll compile the program, Alt F9. Whenever we do some changes, we have to compile it. I'll do Control F9. Okay, this is not looking neat. So what I'll do is I'll add a escape character. I'll save and compile it, Alt F9, Control F9. So now you can see initially I value is 0, sum is 0. I increments to 1, 1 plus sum, that is 1 plus sum is 0, sum becomes 0. Again I increments to 2, 2 plus sum is 1, it becomes, sum becomes 3. So next I increments to 3, 3 plus sum is 3, now sum becomes 6. And 6 plus 4, I increments to 4, 6 plus 4 is 10, so sum becomes 10. 10 again, then I increments to 5, 10 plus 5, sum becomes 15. After I becomes 6, when I becomes 6, it exits out of the loop and will not execute any statement. So this way we can debug, or maybe sometimes if there is an error we can debug. Or if you want to check what's happening exactly in the for loop, you can use printf statement. So I'll delete this. So this time we will use n. We will generalize the program. We will not stick to only 5. We'll generalize the values. We will delete all this comment and I'll say comma n. So if user enters 3, it should add all the number from 0 to 3. If user enters 10, it should add all the numbers from 0 to 10. If the user enters 12, it should add all the numbers from 0 to 12. So we will take the value inside n and we'll check whether I is less than the entered value or not. So I'll save this. I'll do Alt F9. I'll do Control F9. So now it's looking for a value. I enter 5, we get 15 as output. If I do Alt F9, it compiles again. I'll do Control F9. This time I say 10, so we should get 55 as output. So this is how we are getting output. So if we want to check what's happening in the loop, we'll print the statement similarly again. Okay, sum before addition so we'll print sum after addition. So I'll save this. I'll say Alt F9, Control F9. So if I say 4, it should add all the values before 4. So you can see initially I is 0, sum before addition is 0, sum after addition is 0 plus 0 is 0. So again I is equal to 1. I increments 1 in the second iteration of the loop. Sum before addition is 0, sum after addition is I plus 0 is 1. Again I is equal to 2, increments to 2 in the next iteration of the loop. And sum is before addition is 1, after addition 1 plus 2 is 3. And now I increments to 3, sum before addition is 3. And after addition 3 plus 3, sum becomes 6. And I is equal to 4. I increments to 4 in the next iteration. Sum before addition is 6. After addition is 6 plus 4 is 10. And then I becomes 5. So 5 less than 4 is false. So we have entered 4 here. You can see. So 5 less than n. N is 4 and I is 5. 5 less than 4 is false. It exits the loop and it gives output as 10. So this way we can see how is it actually happening inside the for loop. So this time I'll enter. Okay, before that we'll do some formatting here. I'll add a slash n here and we'll give a slash n here also so that it prints one more line. Okay, or else we don't need this. We just use slash t will use so that we'll have a tab here. I'll do Alt F9, Control F9. This time I entered 10. So you can see what's happening here. I is equal to 0. Sum before addition is 0. After addition 0 plus 0 is equal to 0. And in the next iteration I is equal to 1. Sum before addition is 0. 0 plus 1. After addition is 1. So next iteration I becomes 2. Sum before addition is 1. 1 plus 2 is 3. So this way we can see what's happening exactly in the loop. So you can try this way. uh, putting printf statements in the program, so you'll get the output exactly how it should be. So and finally, if I say 6, if I want to add up, up till 6, you can see it comes like this. So if the answer is 21, here is the answer. So all these are debug statements. These are all only for debugging. I have debugging or to check what's happening exactly. I have done. So you can delete this or comment this. The main statement is Control F9. I'll say 6. You can see get the output. So this way we can see how the for loop works. So we'll see one more example of for loop. So here I want to calculate the factorial of a number. So we can calculate factorial of an. I'm declaring three variables x, I and factorial. I'm initializing factorial to 1. There's one more better way of doing a factorial calculation. We'll see it later when we learn functions. So here we have a statement, printf statement. So it will give enter a number on the screen. After that we'll take an input from the user and put it to x. So now I am initializing the initialization statement I is equal to 1 is the step 1. In the step 2, if we enter 3, okay, I will assume that we enter 3 for x here. So I less than or equal to 3, 1 less than or equal to 3, because I is 1, 1 less than or is equal to 3 is true. So it executes all the statements here. We have only one statement. So factorial is 1, 1 into 1, we get factorial as 2. And then after this is the step 3 execution of statements, and the step 4 is incrementation or the loop altering. Here I becomes 2. Now 2 less than 3 is true, less than or equal to 3 is true. So now factorial is 1, 1 into 2, factorial becomes 2. Next I increments to 3, so 3 less than or equal to 3 is true. So now factorial is 2, 2 into 3, 2 3s are 6, factorial becomes 6. And I increments to 4, 4 less than or equal to 3 fails and comes out of the loop. And when we print, we get the factorial is 6. So we'll do the same thing here, we'll print some statements. We'll print factorial is equal to percentage %d, I is equal to, okay, we are using I is equal to percentage %d. I'll use a slash t for a tab. Factorial after calculation percentage %d come on. So we'll print factorial here and we'll print I. So hope everything is fine. So we'll save this and I'll do Alt F9. There's one error. What's error? Factorial undefined symbol factorial. Okay, spelling mistake. Okay, we'll save. Alt F9, Control F9. So it says enter a number, so we'll enter a number. This time I enter 3. Okay, we have not formatted it properly, so I'll use a /n here. I'll save and I'll do Alt F9. I'll do Control F9. So it's looking for a number. So I'll enter number 3. So you can see factorial is equal to 1 before calculation. Okay, still not clear this, so we have to use I need to use a /n here. Okay, I'll save. I'll do Alt F9. I'll do Control F9. I'll enter 3. So now you can see on the first iteration, I value is factorial is 1. We already declared it. So I value is 1. We initialized it here. This one. Okay, then in the first iteration, factorial after calculation is 1 into 1 is 1. Next, after this loop got executed completely, I is incremented 2. You can see I is incremented to 2 and the factorial is 1. So now, before calculation, factorial is 1, I is 2. After calculation, it becomes 1 into 2, 2. Then again, factorial is 2 now, and I increments to 3 in the third iteration of the loop. Now 3 2s are 6, so it's 6, and I becomes 4. 4 less than or equal to 3 fails because we have entered x as 3. 4 less than or equal to 3 fails, and it comes out of the loop and it prints the factorial is %d. That's the %d, it prints 6. The value factorial is 6. So this way we can calculate the factorial of a number. So we'll calculate one more factorial so that you'll get familiar with it. We say 5 factorial, you get 120. So how do we get 120? You can check here. 1 into 1 is 1, 1 into 2 is 2. Now factorial is 2, 2 into 3, I is 3 now, 2 3s are 6. 6 factorial is 6 now, and 6 into 4, I incremented to 4, 6 4s are 24, and factorial is 24 now, 24 into 5 is 120, and next I becomes 6, 6 less than 5 is false, and it comes out of the loop. So this way we can calculate the factorial of a function, factorial of a number. So we'll see one more example. So this is reverse of a numbers. It's a little complicated, but it's really good. So I have declared 3 variables: remainder, n, and reverse. So we say enter a number. The user enters a number, and we'll take that number inside the variable n. So we have to reverse the variable n now. Whatever the value comes in n, we have to reverse it and put it into the variable reverse. So we will start the loop here. So this is our loop. So here you have to observe we have not used initialization statement. We have not used initialization statement for the loop variable. So n, we are not initializing it here. And here we are not using loop altering statement. So these are optional things, but the condition statement is compulsory. So condition statement is compulsory. We have used it. So you can also write a loop like this, for loop. So now we'll assume that we have entered n as 1, 2, 3, 4. Okay, we'll assume this case. So I'll just write the calculation what happens inside the loop here. So now remainder. So I'll enter in brackets. I'll put the values in brackets. Initially remainder we have nothing. So once it's calculated, we'll see what happens. N is 1, 2, 3, 4. Okay, I'm writing the same statement here. So this is not a part of your program. Just for the explanation purpose, I'm typing it here. So I'm writing remainder equals n. Instead of n, I wrote 120, 1, 2, 3, 4. So modulus 10. So modulus 10 is when we divide the 1, 2, 3, 4 by 10, whatever the remainder get, that value will go into remainder. That's 4. Okay. So there is no change in the n value. N value remains there. Okay. This is how the statement is here. So I have written the same statement here, which is available here. So I have written with the values here, assuming that we gave 1, 2, 3, 4 for n. What we get is we get 4 as remainder. So I'll write the same statement here. I'll write this statement now here. Okay. Here n is now 1, 2, 3, 4. Okay. So what I'll do, I'll write n and I'll write in bracket what value will we get after the calculation. So n divided by 10, the 1, 2, 3, 4 divide by 10. So I've written the same statement with the values here. So when we divide this number with 10, we get 1, 2, 3 point something, some decimal values. But here it's an integer division. So the n is also integer. So when we put the value inside the n, so it will be only 1, 2, 3. So n became 1, 2, 3 now. So now reverse. What is reverse? Now reverse, initially it was 0. We'll see what happens after calculation. Reverse is equal to, so the reverse value is 0 initially. So 0 into 10 plus, so I'm writing the same statement here again, plus the remainder is what we got, remainder here is 4. So this is how the statement will be inside the loop. Now 0 into 10 is 0 and plus 4 is 4. So we get reverse as 4. So this is the first loop execution, the first iteration of the loop. It's not the first loop, it's the first iteration of the loop. So now after all the three statements got executed, the loop condition is here. We don't have a loop altering statement, so it goes to the loop condition statement now. It checks the loop condition. Now n value is 123. So now n is 1, 2, 3. So n 123 is not equal to 0 and it's true. So these statements get executed on the second time. Second time, we'll see n value is 1, 2, 3 modulus 10. So we get remainder this time as 3. So 123 divided by 10, we get remainder 3. So again, n is equal to n by 10. That is 123 divided by 10, we get 12. So now reverse will calculate how much it comes to. Now reverse is 4. In the last execution, reverse was 4 into 10. Now in this case, remainder is 3. So 4 into 10 is 40. You can see 4 into 10 is 40 plus 3, the remainder. So now it becomes 43. So this is the second execution of the loop. Second iteration of the loop. So now after this, it again goes to condition statement. Now the n value is 12. So 12 not equal to 0 is true. Again, start executing all the statements. We'll see what happens to each statement now. So now remainder, now the n value is 12. So 12 divided by 12 modulus 10, we get 2 as remainder. And 12 divided by 10, we get n value as 1. In this case, we'll get 1. 12 by 10 is 1. The 1 point something will go, 1.2 will go off. The 0.2 will be truncated because it's an integer and it's an integer division. So now the remainder is 2, and last time the reverse was the reverse is 43. Reverse 43 into 10, 430 plus 3. Oh, sorry, the remainder is 2. Okay, 430 plus 2 is 432. So this is the third execution of the for loop completes. The third execution completes. So now the n value is 1. Okay. So 1 not equal to 0 is again true, because it's not equal to 0, it's true, and again all the statements execute for the fourth time. So now n value is 1. 1 modulus 10 will always give you 1. Okay. So now 1 divided by 10, we get 0, 0 point something, and the 0 will be uh, point 0 will be gone and the 0 will be remaining here. So n becomes 0 in this iteration. So now reverse is 432 into 10, remainder is 1. So 432 into 10, 4320 plus 1, it becomes 4321. So next, after all these three statements executed, now we got a reverse as 4321. So now n is 0. So again it checks the condition here. N becomes 0, and 0 not equal to 0 is false. So it comes out of the loop. So once the statement becomes false, it comes out of the loop. Now the reverse value is 4321. So your new number is 4321 will be printed. So this way it executes in the loop. So I'll delete all these things because for the purpose of explanation, I wrote it here. So you can put the printf statement to check what exactly is happening inside the loop. So I already showed you how to debug or how to check what's happening in the loop. So I'll save this and do Alt F9, and I'll do a Control F9. Now I'll enter a number 1, 2, 3, 4. You can see it becomes 4, 3, 2, 1. So similarly, I'll execute once again. Control F9. So now I'll type 4567. Press enter. It becomes 7654. So this is a simple program. So you need to understand the logic, how it works. Okay. So n modulus 10 gives you the remainder, but the n value is not changed here. So once we divide n by some value and assign it to n, then the n value changes. And again, we are calculating the reverse is initially 0. 0 into 10 is 0. Initial, the first remainder will be added to it. So one by one, we are extracting from the number. If we add 1, 2, 3, 4 other n, if we give input as 1, first this will be extracted and then this will be extracted. So I'll show you with the printf statement what exactly is happening here. We'll type remainder is equal to %d, say slash t. It's just to give a tab space. Escape, it's an escape character, and then I'll type n is equal to %d slash t reverse is equal to %d. I'll say slash n so that we'll see every iteration in a different line. Say comma. I'll copy these things and paste it here. Comma n comma reverse. So we'll save this. I'll do Alt F9. So we have some warning here. Possible use of remainder before use. Okay. So we'll do one thing. It's a warning because we don't have the value in a remainder right now and we are trying to print this. So I'll do Control X. So we'll print it here. So I'll do Alt F9, Control F9. This time I'll print 1, 2, 3, 4. So you can see it initially the remainder is 4 and n by 2, that's 1, 2, 3, 4 divided by 10, sorry, not n by 2, n by 10, we get 1, 2, 3, and the reverse we get 4 in the first time, and next loop remainder is 3 because 1, 2, 3 modulus 10 we get 3, and again 1, 2, 3 divided by 10 we get 12. So we multiply reverse into 10, that is 40, plus remainder is 3. So this way we can check how it's working, how the for loop is working. So I can use the same program. So we saw how to reverse the number. We can use the same program. So I'll comment this. Okay. So I'll use the same program to calculate sum of digits in a number, sum of all the digits in a number. I'll delete this 10. Okay, I multiply 10. You just add the numbers. I will extract reverse one by one and we'll add it to the remainder. Alt F9. Okay, I'll write it here so that you'll understand. Sum of digits is, I'll save, I'll do Alt F9 to compile, Control F9. Now I'll say 1, 2, 3, 4. So you get sum of digits as 10. 4 plus 3 is 7, plus 2 plus 1, 10. Okay. We do Control F9. We do 4, 4, 4, 4, 5 if you want. So we get minus 19. Why? Because this number does not fit in integer. The maximum number that integer can hold is 32767. So we'll do 32767. We'll get it 32767. So it adds and give you the exact output. So if we give 32768, it doesn't work. So we need to use a different variable 768 to get minus values. So you need to be careful with this. Friends, in this video we saw how to use the for loop. So we'll learn other loops in the other video. Thank you for watching this video.